welcome. In this session we are going to be taking a look at cold water and hot water pipe sizing to BS-EN 806. Now this is under mains pressure, so we're just going to be covering mains pressure, so this could be used for sizing of water pipe works for combis and main supplies only. It cannot be used for gravity fed systems. Okay. Right, so we're going to be using BS-EN 806 Part 3 Pipe Sizing Simplified method. This has replaced BS 6700. We will be covering 6700 in another video later, but for now we are just going to be looking at the simplified method because I don't want anybody's brain hurting too much. If you enjoy this and found the video helpful, please remember to drop a like or leave a comment and even subscribe and help support the channel. Right, so let's get started. So the objective of this session is we are going to get an understanding of pipe sizing to BS-EN 806 Part 3. We're going to look at the key terms and symbols and units used when pipe sizing. We're going to look at maximum velocities of flow that we need or we base these sizing on. We're going to look at what loading units are. Then we're going to use a little exercise on pipe sizing for internal copper pipes and plastic pressure pipes. And then one that most people seem to forget about whenever I've designed systems or I've gone into people's properties, they always seem to forget this little bit and it causes no end of havoc. But we're going to look at pipe sizing of the mains coming into the property. So the MDPE pipe work. All right. So the scope of this, the scope of BS-EN 806 Part 3 is it takes everything that we've learned from the Part 1 and Part 2 and amalgamates it, and then we use the pipe sizing to ensure that we meet the requirements as stated. Right, terms and symbols that we use when we're doing pipe sizing. Now this is coming straight out of BS-EN 806 Part 3 and the various symbols and codings of what we need to look at. But there's three main ones that we're going to be looking at for this exercise. Minimum flow rates, you must remember what Qmin means. And this is always measured in litres per second. Now, this is just the minimum requirements of the draw-off. Then you've got QA, which is the actual draw-off requirements, what the regulation state we should be having. And then the last one at the bottom there is the loading units. What I would normally say to my students now is make a note of these three here, so you might want to pause the video, make a note of these for your later lessons. But loading units is a factor taken into account the flow rate required at an appliance, the length of the times the appliance is in use, and the frequency of use. So what they've done is they've looked at every appliance, they've done like time management on them, and they've given them all a specific number. So one loading unit is a collapse of a draw-off that requires a flow rate of 0.1 litre per second, all right, on the QA. All right, so maximum flow rates, flow velocities. Now, to BS-EN 806 Part 3, Table 3, this is where all the loading units and everything is they follow the various velocities. So these velocities are for a header pipe or riser pipe, floor service pipe, maximum 2 meters cubed, 2 meters cubed a second. Okay, so this is how much it was allowed to preserve, or connected pipes to one fitting, dead legs, a maximum of 4. But on average, we use a 3 meters per second. Okay, so 3 meters per second. So we just use that one as our national average. Again, I would get my students just to make a note of the note. So pause the video, make a note and move on. Now, what are loading units? I've already mentioned it. Loading units are the factors taken into account. Length of time the appliance is on, frequency of use. Da-da-da-da-da. So we've got one loading unit is usually 0.1 litres a second. Now, when we start looking at loading units, each thing, so what they've done is they've done these little time studies and use studies on these various appliances. Let's get my little pointer here. All right, they've got all that there. We've got wash hand basins, bidets, WC cisterns. They are 0.1 litre per second for max, well, the normal draw off and minimum draw off. So these given a loading units of 1. What have we got here? Kitchen sinks, washing machines, dishwashers, sinks and shower heads are given 2 loading units. A urinal flush. This is a fairly new thing that I've not seen many out there in the world because there was a few problems with them coming in and being passed. But there are a couple of pubs and restaurants now that have them. These are little flush valves that you whack on the wall and it flushes the urinal. These are given a loading unit of 3. Your domestic bath has a loading units of 4. Taps to gardens and garages, they have 5. Then you've got non-domestic sinks or baths. So these are baths that are over 250 litres in size. They should be given 8 loading units. Then you have these flushes here. These are again large quantity flushes. They would have 15. We don't rarely come across these two when we're designing for domestic use. If it's an undomestic appliance, though, you must refer back to the manufacturer's instructions. So, when it comes to pipe sizing, we've got to look at the dwelling. Okay, so when we start doing this pipe sizing, one of the first things I do is I draw out a rough drawing of how the system looks. I'm not after lengths, I'm not after how many elbows was in that pipe work. I'm just doing a rough drawing, okay? Nothing too spectacular. We will have some T's in there. We will have the stop tap, but I don't tend to worry too much about how many elbows and how wiggly and how long it is getting to these appliances. So, I've done a little example for you. One of the simple drawings that I would do is something like this. So, there's my main stop tap coming in. There's my symbol for a drain off, because you should always have one of them, because we are apprentices, come on. Or we are plumbers, so we should always be fitting them anyway at the bottom. Then you'd see there I've got a tee off to a washing machine and a kitchen sink. Then it goes upstairs. Again, there could be loads of wiggles, I don't know. Basin, bath, WC. So your toilet. So it's just a basic, simple house layout. This is something that I commonly use in people's houses. So we've got that bit. Now, once we've done the drawing, you've got to break it into its sections. All right, so you break it into its sections, but you start at the furthest point. So as you break it into the sections, you start at the furthest point, work your way back, and then you go to the next bit and next bit. So I've done the example on the next slide. So we'd start off at the WC because that is the furthest appliance on the run. Then it would be the bath. So we've given this WC section. So from the bath T to the WC is section A. From the basin T to the bath is section B. Then from the T it goes upstairs to the basin, that is section C. Then we move over to the sink, D, washing machine, E. Then the little bit between the T and the stop tap would be F. And then I always add the bottom one there, which is the G. This is the main pipework coming in. Okay. Now, next thing we look at is our loading units. So we know we've got a wash hand basin, a WC, a bath, a kitchen sink and a washing machine. So we need the wash hand basin, WC, loading units. They are loading units 1. So we remember the loading units 1. We have a domestic sink, kitchen sink. We have a washing machine. They are loading units 2. So we remember the loading unit 2 for them. Then we have the domestic bath. That has a loading unit of 4. So we remember them and we take this information and we put it next to our appliances. Now we've got all that bit sorted, we can move on to the next part. Now the next part is very straightforward. We look at section A. Yep, we look at section A and we total up how many loading units is on section A. Well, on section A we've only got the WC connected, so there is 1 loading unit. Then we look at section B. We have a bath and the WC now connected. That's got to get the flow from there. So that will have 5 loading units. Then we look and say to C. So that's going to have the basin, the bath and the WC. That's going to have 6. Then we move on to section D. There's only the 1 sink, so that's going to have 2. Section E, we're going to have the washing machine and the sink. So it's going to have 4 loading units. And then F is going to have all them loading units connected to it, so that comes out at 10. Dead easy, nice and straightforward. That's our first bits done. Now we've got this information there, we can move on to our next part. The next part is we look at table 3. Now table 3 is broken into 8 parts, depending on what material you're using for your pipe sizing in your property. Column 1 is copper. Also you can use this one for plastic pipes, pressure pipes, but we also have stainless steel, hot dip galvanized, PEX, PDE, PB, PP, PVCC. This one is chlorinated, this one is resistant to chemicals. So you tend to only use these in places where there is chemicals coming through the pipe works and you need to protect it. So laboratories, places like that. And then your MDPE, your underground pipe work, is table 3.8. So what we're going to do today though is we're just going to look at table 3.2 and 3.8. So there is table 3.2. This is for copper pipe work. So as you go along the top here, you can see we've got our maximum load. So this is where our loading units go in. Then we've got the highest value. This is the highest thing that's running on this size of pipe work. We must be below that or not be above it. Then you've got your pipe diameters. Nice and straightforward. Then the next one down, the next row, there's a go, my brain froze then, is the internal diameter and then the maximum lengths run of these pipes. These are the recommended maximum lengths. Once we start going into the 18, 22s and all that lot, there is no maximum lengths, but in 12 and 15 we do have maximum length requirements. This is when we start worrying about the lengths. Right, so first things first, that was on our list there was section A. So that has got a loading unit of 1. So what we do then is go onto our table, we find our max loading unit, 1. We go down and we find our max diameter of pipework, which is 12. So the minimum requirements that this document says, with no sums, no expected calculations, we need 12 millimetres pipe to supply water to that toilet. Now, in the UK, we use 15 mil as our smallest pipework to supply water around a home. Reasons why is 12 mils we tend to use for central heating, and the fittings and pipework can be quite expensive, and we're not going to use it for cold water because it adds extra restrictions. So we tend to up it. We go, yeah, we can get 12, but we tend to go to 15. So now what we can do is we can put that on our little table there. So section A, 1 loading unit is going to be 12 millimetre pipe. So now we'll go for section B. We have the BAF and the WC, so we've got 5 loading units. So we go back to our table and we have our 5 loading units. There isn't 5 on there, so it can't be 4, so we go up to the 6. So it's got to be the same as or less than, or you go above and then you go to the next one over. Now, this column here now kicks in, highest value. So the highest value that we have is the BAF, which has 4 loading units. So we can go along this line. Luckily, that is 4 loading units, so we can use this. So we can use 15 mil pipe to supply water to both the BAF and the WC without any problems. Now, so we've got our 15 in there. BAF taps, as most plumbers will know, they have a 22 mil connection. Me personally, and the design side of it, BAF's 22 mil, so I will run the pipework to the BAF in 22 mil pipe. You can't really go small to large to small again because it doesn't work. Yes, you could go 15 mil and put a reducer onto the tap and just connect straight to the tap. You could do that, but I prefer not to, so I would say mostly used is 22 mil pipe. So bear that one in mind. So again, we can put that one in there. That is 15. That was the minimum requirements. So we can now go to section C, where it has 6 loading units. So we can put that in there, 6 loading units. The BAF is the highest thing. So we can go, yeah, we're fine. So again, we can use 15 for that. But again, as it's the bath is connected to there, I personally would be using 22mm. But the minimum requirement is 15. So we have now sized from this T here in 15mm pipe to the basin, all 15 to the bath, and then we drop down from 15 to 12mm to the WC. That is that section done. So now what we've got to do is go to section D, where we've got the 2 loading units. So again, nice and straightforward, we go on to there, 2 loading units. The maximum or highest value that we're allowed on there is a 2. So again, we are still safe, we are sorted. So we can use a 12mm pipe. Again, I personally, and generally in the UK, we use 15mm pipe to supply water around the property. So minimum standard though says we can use 12. Oh, I went a bit fast then. Now we look at section E with the 4 loading units. So we go 4, we highlight the box. There's no real height than 2 on there, so I don't need to worry about that. So that determines it's got to be 15mm pipe. Job done. So we can drop that in there. So now, according to this system, this is all 15mm pipe up to the washing machine. Then it drops down to 12mm for the sink. And again, the sink connections, washing machine connections are 15mm. And it's the same with the WC as well. The connection to that is usually 15mm. So you would have to fit a reducer to go from 12mm up, or you could just use a bit of 15mm is what I would do. So we've now completed all this section here. So we're left with F, where we've got every appliance, the whole house connected. So we have 10 loading units. So we go to the 10 loading units. Lovely. Maximum load for one appliance is 4, so that's the bath. This is 5, so we are safe. So according to this, we can use 18mm pipe for our connection. Again, on this though, in the UK we don't tend to use 18mm pipe because the cost of the pipe and the fittings is a lot more than 22mm pipe. I know it sounds odd, but it is the way it works, and we tend to only use 18mm on Pacific specialist jobs. So we normally go with a 22mm. So we can whack that in there. Job done. So that is all the copper complete. Now, when it comes to plastic and the copper, we use exactly the same technique. We use exactly the same table for pressure pipe. It won't affect it in any way. So you should be fairly safe on that situation. Now, if you sized all these correctly, this property should work beautifully as long as the mains pressure coming in and the flow rates are correct from the water undertakers. They haven't turned it down because they've got too many leaks in the streets and things like that. And basically what should happen is someone should have the upstairs tap on, usual washing their faces, or they could be in the shower, whatever they're doing, and then someone could turn the tap downstairs on. They should both stay the same rate with no problems. If you undersize it though, the upstairs tap tends to be the one that gets starved. It'll either slow down and I've even known them to stop. So you've got to get the pipe sizing correct. All right, so bear that one in mind when it comes to fault finding. If you go into someone's house and they say, oh, whenever I go upstairs, I turn on the tap to wash my face, someone opens a tap downstairs or the washing machine turns on downstairs, the water stops coming out. That is usually a sign of undersized pipe work. So you can then do this technique and give them a quote for giving them the correct size pipe work. But all that will be pointless if the mains pipe coming into the property is incorrect. If that is undersized, you're wasting your time. So you must do the MDPE. So again, we go to table 3.8. So we have a look at our little table here. The MDPE is usually connected just below the main stop tap. So that is my section G. So again, it's only got 10 loading units. So we go to the 10 on there, job done. The highest value is the bath. Well, it's less than the 5. And then that means we can use 20mm MDPE pipe to supply to this property. Now, that to me is perfect. no problems there. I've got no worries about installing it, so that would be a good job. So we'll usually get that straight in there. But I'm just going to remind you, I'll just move my dot, that if you undersize this, it doesn't matter how perfect you've got your pipework running in that property. If that mains is undersized, you've wasted your time. So if they put an 18 or a 16mm pipe in there, you've lost 4 loading units for 18, 5 loading units for the 16mm. So you have lost the battle already. So again, if the customer's complaining that they're not getting enough flow, but all the pipework inside the house is correct, then it's the external pipework. So you've got to get that sorted. So again, nice little trick. Could get quotes from that one if you don't mind doing the mains outside. So I'll add that into my little book there. So that would be 20mm. Now that is to the minimum requirements. But remember, in the chat, as I've been going through this video, I've said that in the UK we use different things. So I would make my adjustments and I would set it up like so. So as you can see on here, I changed this 12 to 15, this 15 to 22, this 15 to 22. This is all 22 coming in, and that is 20mm there. And then this would stay as 15 because that's spot on. It's only supplying a washing machine and a kitchen sink. So we're happy with that. And I'd swap that 12 to 15 as well. But the only thing that you've got to remember is your maximum lengths. Remember when I talked about 15s and 22s? They have the 12mm and the 15s, they have maximum lengths for each section. But we'll go back there another time and have a look at that. So that is your basic simplified cold water and hot water mains pressure pipe sizing. So in summary, you should now have a better understanding of how to use the pipe sizing in BS EN 806 Part 3. The key terms, the symbols, the units, maximum flow rates of velocities, what are loading units, and you should be able to, in theory, be able to size a cold water main for your property or your dwelling that you are in. And you could also size the MDPE. So what I'm going to say is, why not try it out on your own property? Go back to the video, to the table 3.2, and see what the system says your pipework should be in your property. Find the mains. How does it tee round? Just do a rough drawing and work it out and see how you get on. If you have any questions, though, please leave them in the comments below. I do check them regularly, so if you do need help, I'm usually around to check. But you never know, someone else in the chat might be able to help you as well. So, if you did enjoy the video and found it really useful and helpful, please remember, drop a like, leave a comment, and even hit that subscribe button and help support the channel. Thank you for watching. I really appreciate it. If you got this far, thank you very much. And thank you for your support. And I will catch you in the next video. But for now, bye-bye.